example 14, we've got an improper fraction because you've got a quadratic divided by a quadratic. So quadratic and the quadratic in the denominator. If the degree of the polynomial in the top of the fraction in the numerator is equal or is greater than the degree of the polynomial in the bottom, then it's an improper fraction and we need to divide first. However, if you are given the form that you are aiming for, like in this question, you can avoid dividing by multiplying through by the denominator and then using comparing coefficients method to find the values of a, b and c. So we'll have a go at doing this after we've done the dividing method first. So when you expand the two brackets in the denominator, you get x squared minus 3x plus 2. So let's divide the quadratic by this quadratic. So remember, the grid needs to be filled in with the quadratic. So it's going to be 3x squared. How many x squared in 3x squared? It's 3. 3 times minus 3x is minus 9x, and 3 times 2 is 6. The rest here is going to be the remainder, and we have got 3x squared, we've got it. We haven't got minus 3x, we've got minus 9x. We need to adjust it to give us 6x. There you go, so adding together gives us minus 3x. And then minus 2, to obtain minus 2, we need to subtract minus 8. And then we have got everything inside the box adding up to our numerator. So at the moment I could see that the answer is going to be 3. How many of these quadratic in the top? 3 plus the remainder of 6x minus 8 over whatever we're dividing by, which is in factorized form x minus 1, x minus 2. Okay, so now we can focus on this fraction over here and split it into partial fractions and then add it to 3. So at the moment we know a is equal to 3. Now 6x minus 8 over x minus 1 multiplied by x minus 2. That is altogether going to be equal to b over x minus 1 plus c over x minus 2. Let's multiply through by the denominator. You will have 6x minus 8 equals to b. b will be getting x minus 2 because it has got x minus 1, and c will be multiplied by x minus 1. Substituting x equals 1, we are going to have 6 times 1 minus 8 minus 2. This part involving c will disappear, and over here we'll have 1 take away 2, so it's minus b, giving me b equal to 1. The second value to sub is 2, so if you put 6 times 2 minus 8, 12 take away 8 is 4. This part here involving b will disappear, and c will be multiplied by 2 minus 1, which is 1. So c is equal to 4. So the answer altogether will be 3 plus the value of b is 1, so it's 1 over x minus 1. The value of c is 4, x minus 2. Now, I said I will show you a different way of doing it. If you have the form already provided, you can multiply it through by this denominator straight away, and then you've got 3x squared minus 3x minus 2 is equal to a times x minus 1, x minus 2, plus b will be multiplied by x minus 2, plus c, which will be multiplied by x minus 1. And then you do the same as before. Substitute 1 in, and this time you will have 3 minus 2, so it's minus 2. That will go to 0. That will give us minus b. So b is equal to 2. Just double check. If I put 1 into that, that gives me minus 2. Why did I have b equals 2? Oh, b is equal to 2 here. Yeah, I was thinking I made a mistake. There you go. So that's good that I'm doing it the second way to correct my mistake. The second value to sub in is 2. So if I put 2 into this, it's going to be 3 times 4, which is 12, minus 6, and minus 2. That should give me 4. And on this side, that will go to 0, that will go to 0. This one here will give me C. I did get C. So finally, let's check a different. Choose a maybe x equals 0. And then you're going to have 0 minus 0 minus 2. So it's minus 2. Over here, you will have minus 1 and minus 2 times together give me 2a. Over here, we'll have minus 2b and then minus c. Let's substitute the values of b and c. You have minus 2 is equal to 2a, minus 2 times 2, which is minus 4, and minus 4. So 2a is going to be minus 4 becomes plus 4, and so plus 8, that gives me 6. So a is equal to 3. You get the same values as before. There you go. So now that takes you to exercise 1G, and it's the next exercise that follows. Okay, just a reminder, something I haven't made it explicitly, to identify an improper fraction, you will have to have the degree of polynomial on the top equal or greater than the degree of the polynomial on the bottom. So it could be a quadratic over quadratic, a cubic over quadratic, a quartic over cubic, etc., etc. Okay, thank you.